Hi, welcome to Concept Based. I'm John Hepworth, and this is a Year 11 advanced topic. We are in Introduction to Differentiation. Still lots of videos in this section. We're down in the last part here, the derivative as a rate of change. Now, this one's really interesting because in advanced mathematics, you're going to find two cohorts of students. You're going to find one cohort of students that are doing physics and one cohort of students that are not doing physics. Now, this can be a slight problem, especially for Extension 1 students in the advanced course that are not doing physics, as projectile motion is a whole topic upon itself in Extension 1. Now, of course, you can't use physics formulas to do mathematics and write proofs and so forth, but a general understanding of what's going on is typically achieved by students doing the physics course about these types of motions and rates of change, whereas the understanding has to be achieved by students in the mathematics course only when they're not doing physics as well. So I'll do my best to describe this question to a non-physics advanced student to try and clarify some of the misconceptions, because we are here at concept based, that those students will have. So the question is, given the following graph of x of t, find the distance traveled between 0, t is greater than or equal to 0, less than or equal to 4/3, and the velocity when t does equal 4/3. And this is the graph that I've got here. Now, there's a couple of things that I really need to draw out. First of all, I want you to notice that the label on this axis here, if my pen is going to write, there it is x. So this is the only time that we're actually putting x on that vertical axis, because we have t down here. I'm using Desmos. I would love it if Desmos would give me the ability to make these characters, the text a little larger. But down here we have t on the axes. So it's not a graph of y versus x. It's a graph of x versus t. Now, why is that? Well, that's because x is the displacement function. So x is telling us where the particle is that's moving along in a in a one-dimensional direction, not two-dimensional because we're not in projectile motion yet, one-dimensional, along an axis, along the x-axis. It's moving left or it's moving right. Right being positive, left being negative. My camera's mirrored, so descriptions like that don't work awesomely when I'm saying things like this. This is my right hand. Okay. With this function here, with this, what we can see, this x of t, we can see that the particle has started off originally when t equals 0, that's when initial conditions occur, that it's initially started here at a position 1. So that means it started 1 unit to the right of the origin. It's then moving towards the origin, and it gets to the origin here at this point. It then goes past the origin to the left-hand side, and we have this point down here, which I'll read the numbers because they're a little bit small on the screen. And then it moves back to the origin. Here it hits the origin again, and then it moves off to the right-hand side. Okay, so we've got some movement across past the origin, then back off to the other side. But the question is asking us a very specific question. It's asking us, find the distance traveled. Now, distance is very different to displacement. Displacement is how far away an object is from another one. That's the displacement between the two. But the distance traveled takes into consideration all of the time that's gone before it, or that's included in the range. And you can see that the range, I'm saying range, but really the domain of time that we're using is from 0 up till t equals 4/3. So we're actually going from 0 here, from 0 all the way to this point here on the graph, right, that we're talking about. We're wondering what distance was covered by the particle across there. Now, the answer is obviously not 4/3. That's the amount of time that has gone past. 4/3 seconds, 1 1/3 of a second, has gone past while we moved from where we were initially through the origin to this point where we see on this graph. But the distance that was traveled, so we started off at 1 and we traveled all the way down to the origin. But then we went past the origin and we ended up down here at this value. Now, this value here is 5/27. So the distance that the particle has traveled includes all of the distance that it travels all the way to the origin, and then it includes the distance it travels past the origin to the left-hand side. Now, these values don't have direction. We're not saying +1 minus 5/27ths because we're just looking at the sum distance that this particle had to cover to go between those 2 points. So therefore, it had to travel one unit, it might be meters, and then it traveled another 5/27ths of those units to get us to a point where we have traveled 1 and 5/27th units. Whatever the units are, you don't get marked incorrectly in the HSC for incorrect units in mathematics. So 1 and 5/27ths is the answer to the amount of distance traveled between 0, t is greater than or equal to 0, t is less than or equal to 4/3. But then there's a second part to this question. It asks us to describe the velocity at this point at when time is at 4/3. So that's here, time's at 4/3 here. And we're then asked to describe the velocity. Now, velocity is the rate at which the displacement changes. The rate at which the displacement changes. And this is the whole crux of this section of the syllabus. The derivative as a rate of change. So the rate of change is the derivative. So if we were to look and try and describe velocity given a displacement graph, then we would be wanting to consider what is the derivative of it at that point. So let's just take a random point, not the point we're looking at. If we were talking about this point here, the derivative at that point there is going to give us a tangent. So we're going to get some sort of straight line that's going in this well, that's definitely not going in that direction. That's going in this direction. So we would say its velocity at this point would be negative, right? It's less than or equal to 0. It's not equal to, it's less than 0 because it's heading downwards. You know, it's a negative gradient at that point. So we can describe velocity based on its direction, in this case downwards or to the left, we could say, because we have just defined displacement, right is positive, left is negative. So this velocity means the particle's heading to the left, which is negative velocity. We wouldn't say negative speed, but that's another part that is actually in the syllabus. It does say and distinguish between velocity and speed. Speed would never be negative. It would just be the value of the gradient that it's going. We don't care which direction it's going in. All right, now let's look at the point it's asking about. T is at 4/3. So here we are at this point. Now you can see that this point is on the bottom of the curve where it dips exactly. So if we were to go and do a derivative and find a tangent at this point, the line that's the tangent is flat. So therefore, the velocity would have a gradient of a flat line, and the gradient would be 0. So the velocity when the time is at 4/3 is actually equal to 0 because it's not moving. Now, again, this is obvious to physics students because they talk about particles doing things like that. Let's talk more about what's going on here. So the particle starts to the right, it moves through the origin to the left and slows down and then stops, velocity equals 0, and then turns around and goes back towards the origin and beyond. So at some instantaneous point, that particle has stopped and turned around, and therefore its velocity at that point must be equal to 0. So, students that aren't doing physics, the velocity is the rate of change of displacement. So it is the derivative of the displacement function. We would often write that v of t is equal to the derivative, or often you might even see the dot above it, of t. The derivative of x, sorry, not of t, of x. The derivative of x is going to give you the velocity. So you're thinking in terms of those tangents and so forth at that point. We were given a point, so the velocity at 4/3 is equal to the derivative of x of t with 4/3 subbed in. And if we did sub in 4/3 to this function, the derivative function, we would get 0 because we can see the gradient, the tangent at that point is 0. If you are not a physics student and you are in advanced mathematics, do as many of these questions as you possibly can. Do the problem-based questions that are in your textbook. Do the extension questions that are in your textbook, because those physics kids have just got a little leg up on you in terms of understanding of what's going on here. If you are an Extension 1 student in the advanced course, make sure that this part of the syllabus is absolutely fundamentally understood, because we are going to go into projectile motion where we don't just have particles moving left and right on the x-axis, they're going to be fired and move in x and y also in relation to time, so it is going to get more complex.